welcome to Venn diagrams. So before we get going, just a reminder that there is a notes jotter available for this video. If you just check the description below for a download link, you can download the sheet and you can work along with me as we go through the video. Okay, so we've been asked to complete the Venn diagram to represent this information. Now, before we get into the actual question, we better have a look at some of this notation. So first of all, we have this squiggly letter E. Now, this is actually the Greek letter psi, and it's the symbol we use for what is known as the universal set. Now, all that means is the word universal generally means everything, and in this case, it's everything we're interested in this particular case. So it's everything that we want to know about. So in our example, it's the integers from 1 to 10. Therefore, the only numbers that are in our diagram are the numbers from 1 to 10. The little brackets, you'll see you've got squiggly brackets. Those brackets are used to actually denote the contents of a set. A set is just a group of values which are related in some way. And so, in our example, we have the universal set, the integers from 1 to 10. And so the first thing I'm going to do is I'm actually just going to write down what those numbers are. So I know in this question which values I'm actually dealing with. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I've also then got my first set, set A, which are prime numbers. Now we're only dealing with the list that we've got at the top, but I want to know all of the prime numbers that will be in that list. So we haven't got 1, but we have got 2, we've got 3, we don't have 4, we've got 5, not 6, 7, not 8, not 9, not 10. So the first set, A, is the numbers 2, 3, 5 and 7. And B, the factors of 10. Well, in this case, we're looking at the numbers at the top, and the factors of 10, well, that would be 1, because 1 times 10, 2, because 2 times 5, 5, because 5 times 2, and 10, because 1 times 10. So now that we know what the contents of each group is, it now comes to the actual Venn diagram itself. And the Venn diagram basically shows us a collection of sets, and they have an overlap. The overlap means members of both groups. So in this case, we can see that if we have a look at our set A and our set B, the number 2 is in both lists. And because 2 is in both lists, we'll place the number 2 in the overlap. We can also see that the number 5 is in both lists, and so that will also be in the overlap. We then start looking at the other elements of the groups or the sets. And so set A also has the number 3 and the number 7. And so they are going to be in the circle for A, but not in the overlap, 3 and 7. If we look at set B, well, we still have the number 1 and we still have the number 10. And so they will be in the B circle. Now there is a box around the outside. The box around the outside is because we have to still think about this universal set, everything else which is available. Now we've already used the number 1, we've used the number 2, we've used the number 3, 5, 7 and 10. And so the other values need to be placed in the diagram as well, but they will go on the outside of the circles. So we'll have 4, we'll have 6, we'll have 8 and we'll have 9. That is our Venn diagram completed for this situation. So next I'm going to look at a little bit more of the set notation for the operations, and that is because we can be asked about certain areas within a Venn diagram. And so the 3 most common types are this N shape, this U shape and the apostrophe. And each of those has its own definition and meaning. So the first one, that is the intersection symbol, and it's usually read as and. So this first statement would mean in groups A and B. The second one is known as union, and we usually read that one as or, and so this would be anything which is in group A or group B. The last one, the little dash, now this one is actually the complement, and basically we usually read this one as not, and so this means anything which is not in group A. Right, so let's actually see if we can put some of that into action and see what each of these expressions actually means about our diagram. So I'm going to highlight in each case the sections which are important. So identify the areas of the Venn diagrams which will be included in each of the expressions. So the first part is the A and the little N shape B, meaning A and B. Now the area that is A and B is the part where they overlap, and therefore what we're actually dealing with is this central section, the overlap. In the next one, if I'm looking for A or B, well that means it can be in A, which would be here, or it could be in B, which would be here. And what that actually means is we include the overlap as well as everything which is in the A circle and the B circle. If I'm looking at not A, well that means we want to include anything which is not a letter A or set from the set A, which means we can't have anything in the circle that is called A. And so we would have these pieces, which are B, but not including the overlap because those parts are also in A. But in this case we can't forget that also we have all of these elements that are around the outside as well. We have everything within the universal set which is not the letter A. If we do the same but looking at the next set of values, not B, well that means it cannot be anything in the B group, and so again we are going to deal with any value that is outside of the group known as B. The next one, now this one we're starting to get a little bit more tricky, but we've got not A and not B. So not A, not B, and it has to be both of those things. So it cannot be A and it cannot be B. And so if it cannot be A, it has to be outside of the A circle, and it can't be B either. So it has to be outside of the B circle. That actually leaves us with this section around the outside. It's actually everything else within the diagram that is not in the circles. If we look at the next one, we've now got brackets, and so we have to read, just like we do in everything in maths, the brackets need to come first. So this is A or B, but then the apostrophe afterwards tells us that it's not A or B. So the first thing is to identify A or B. Well, we've already done A or B. That was everything that's inside of the circles. And so if we're going to have not A or B, well, we're going to have everything on the outside. In fact, this is exactly the same as the previous question. They are the elements that are not in either group A or B. And into our final selection, we've got A and B, but then the not symbol. So A and B is the intersection. So that's the first thing we would want to mark, that we are dealing with the intersection. That is A and B. But in this question, we've been asked for not A and B. And so we're going to look at absolutely everything else within the diagram that is not in that section. Next, we have A and not B. So this means we are looking for everything which is A and it is not B. So not B would mean we can't use anything in this circle. And then, because it has to also be A, it means we're actually dealing with the pieces which are in A but are not in B. And so we are actually dealing with the little piece highlighted there. And finally, A or not B. So things in this one can be A or they can be not B. And so it can be A. So everything within that circle is A. But also, because there is an or, it means it can also be anything which is just not B. And if it's not going to be B, then that means we want to ignore everything which is inside of the B circle, but take anything which is outside. And so we are just going to ignore the pieces within the B circle outside of the overlap. Okay, so let's put those two bits of information together. Let's create a Venn diagram, but then also start looking for some probabilities by looking at the areas within the Venn diagram. So in this case, we have our universal set being the even numbers less than 20. And just like we did before, what I want to start by doing is just writing down what numbers they would actually be. So the even numbers less than 20, well, they'll begin at 2, and 4, and 6, and 8, and 10, 12, 14, 16, 18. And importantly, it is less than 20, so that's not including the number 20. And then we're going to look for the factors of 24. Now in this case, we are only dealing again with the numbers which are above, so not necessarily all of the factors of 24, only from the list that we've just created. So does 2 go into 24? Yes, it does. Does 4 go in? Yes. Does 6? Yes. Does 8? Yes. Does 10? No. 12 is a yes. 14, 16, 18 are all no's. And then again, multiples of 3 is set B. So we're just looking again at the list of numbers that we started with as our universal set. Which ones are multiples of 3? Well, we have 6, we have 12, and we have 18. They are the multiples of 3 which are in the universal set. So, to start building the Venn diagram, again, we're interested now in sets A and B, and we're interested in what is in both groups, because that's where we want to start. And so there's a 6 in both groups, so we'll put a 6 in the middle. There's a 12 in both groups, so we'll put the 12 in the middle. If we then look for set A, well, the values that are remaining in set A are 2 and 4 and 8. And if we have a look at the values which are remaining in the multiples of 3, it's just 18. And then to finish, we need to look at that outside area, the elements which are left over in the universal set which we haven't already used. So take out 2 and 4 and 6 and 8 and 12 and 18. So we are left on the outside with 10 and 14 and 16. So next comes the questions about this set. We've been told that a single number is selected at random from the set psi. Now that is the universal set. Find P brackets A N shape B. So now we have more notation. If we see the letter P in front of a bracket, that means the probability of. So we're looking here for the probability of A intersection B, or A and B. So where in our diagram is A and B? Well, let's use a highlighter to show. Probability of A and B, well, that is the overlap between A and B. It is right there in the centre. And so that gives us two different possibilities. So we have two values. And probability means we need a value for it to be out of. And that means, basically in this case, how many values did we start with? And if we have a look, the even numbers that were less than 20, there were 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And so our first probability is 2 out of 9. If we then want to look at the probability of A or B, now again, we need to be thinking about what that means. If it's A or B, well, that means it could be anything in the A circle or anything in the B circle. And so it's everything in here this time. And so all we want to do is once again count how many values that actually is. We've got 1, 2, 3, 4, 5, 6. 6 different values that work out of 9. Now, we haven't been asked to do it, but we should always try and simplify fractions if we can. That would be the same as 2/3. And finally, the probability of not A. So, different colour again. It's not going to be A, which means we don't want anything in this circle. But we do want anything else. And so we're actually looking in this case at anything outside of the letter A circle. And so in this case, the values that we're interested in, 18, 10, 14, 16, there are 4 of them. 4 out of 9. And finally, we come to our exam question, and this came from the Edexcel paper in June 2017, and it was on both Foundation and Higher Paper 3. This is a crossover question, that's why it was on the Foundation and Higher papers. And in this one, we've been told the universal set are the odd numbers less than 30. And then in A, we've actually been told the actual elements of the set, 3, 9, 15, 21 and 27. And the B has the elements 5, 15 and 25. It asks us first of all to complete the Venn diagram to represent this information. So the first thing I want to do in this question is I just want to list what numbers would be in the universal set. And we're dealing with the odd numbers. So that would be 1 and 3 and 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27 and 29. Now I'm just doing that so that later on I can just check that I've definitely got all of the values in my diagram that I need. And so what we've done each time is look for the values which are in both set A and B. And before we do that, we should actually mark that we do need to call our circles A and B. And the overlap is where we want to start. Which numbers are in both lists? Well, if we have a look, 3 is only in the A list, 9 is only in the A list, 15 is in both of them, and that is actually the only one. So then we just want to take the remainder of the values which are in A. So we've got 3 and we've got 9 and 21 and 27. And the values which are left over in B, we've got 5 and we've got 25. Now, this is where the list that we made at the start comes in quite handy, because if I now have a look through, I could say that I've used 3, 5, 9, I've used 15, I've used 21, I've used 25, I've used 27. And so everything else there that is in the list must be on the outside of my diagram. And I'm just going to try and make the best use of the space I can. So 1, 7, 11, 13, 17, 19, 23 and 29. That's the first part of the question completed. We have completed the Venn diagram. Now we start to look at a bit of probability work. So a number is chosen at random from the universal set. What is the probability that the number is in the set A and our little U shape B? So first of all, there's going to be a probability. So that probability is going to be out of the number of numbers we began with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. And then it comes to this phrase here, A, U, B. So we're looking for A or B. What does A or B look like within our diagram? Well, that means it can be in the A group or in the B group. And so it's everything within those two circles. How many elements is that? Well, we have 1, 2, 3, 4, 5, 6, 7. And so there is our probability, 7 out of 15.